Well, hello, I'm here with Caitlin, and the Cisco devices are owned. But first, Caitlin wants to tell us about Voyager.
Right. So first, I want to apologize to our fans. I've been gone for a while. I've been super busy at work. And hopefully this won't ever happen again. I was basically told, you have like a week or two to do all this work. And I was thinking initially I had like a month and a half. And I thought it would take a day. Ended up taking like 2 weeks. Anyway, I'm back, and it's time to stay. And so our first article is about the Voyager space probes, which, as our viewers will remember, were sent out back in the 1970s. And the Voyager probes have been traveling to and through interstellar space. So they're very far away, light hours or even light days at this point, away from Earth. So they're very far away. They're outside the heliopause. And they need a software update. So this is going to be the furthest software update ever done on a system, and it's going to be live. So they're gonna, let's cross our fingers. But this is an article on Ars Technica by Stephen Clark, and so essentially what's happening is that the Voyager, and there we see an old picture of Voyager on the ground. It's a relatively small probe, but it has gone out very far. And the arm at the left there, that's measuring the magnetic fields variations. It's really cool. Anyway, so what happened is that the probes are starting to send back incorrect telemetry data. Oh, there it is. Yeah, the magnetometer. Boom, there it is. It's sending back incorrect data, so that it needs a software update, and they're going to send it, I believe, to which one? They're going to go to Voyager 2 first, which is closer to Earth, and then they'll send the same patch to Voyager 1. And apparently the problem first started in 2022, and the computer software that orients Voyager 1 was sending back just nonsense. And so, yeah, it just needs a software update. So that's what engineers are going to be doing to the Voyager probes.
Yeah. I was amazed when I learned about the heliopause. So the solar system is like a cell. There's like an edge that's really like turbulent.
I mean, think of it like the Earth's atmosphere. Where does the Earth's atmosphere start and where does it end? You can say, okay, it starts on the ground. Okay, that makes sense, except that there's caves and stuff, and there's air underneath the ground. Okay, well, that's weird. And there's air in the oceans. And then you say, okay, well, where does space begin? Well, usually we say the Kármán line. That's about 80 kilometers up. And except that there's still air up there. There's still drag. Stuff will still fall. Okay, well, okay, maybe higher. Well, it turns out that there's like little hydrogen atoms around Earth that extend outside the moon orbit, believe it or not. So that it's the same thing with the solar system itself. Where does it begin? Where does it end? I mean, it's tough to really pinpoint an exact place.
But Voyager went through something that really had strong magnetic field changes, and they said it could even like damage things. So there is like an edge of some sort it went through.
I mean, yes. It's sort of like the heliopause is sort of like the outer distance of the solar system, where it sort of transitions to the interstellar medium.
Yeah.
And so there's a certain amount of like magnetic field that sort of reflects the interstellar medium. So one of the big mistakes when thinking about space, especially if you're just getting into this, is to think of space as a pure vacuum. It is not a pure vacuum.
Yeah.
The Earth's atmosphere gets lighter and lighter and lighter, but there's still atmosphere. And like we just said, it can go out beyond the moon, and there's still atmosphere beyond the moon, and there's atmosphere beyond Jupiter. It just sort of collects and varies in different parts of the solar system depending on where you are.
But the Earth's atmosphere just gradually fades and fades and fades. There isn't like some sudden abrupt change anywhere, right? It just gradually decays.
And the heliopause isn't really an abrupt change either.
Okay.
It's just the point where the sun's magnetic field sort of can't distinguish between the interstellar medium and the outside medium anymore. And so let me pull up something here so we can look at this. Let's see. Here we go. So here you can see what the heliopause sort of looks like visualized, where you have the radiation from the sun creating this sort of magnetic field around. Let's see if we can't move forward here. Here we go. So yeah, sort of looks like that. That's a good example. Let's go back.
So there is like some turbulence in the front where it's colliding with some kind of solar wind or something, right?
Exactly. So there is some, but it's not a sharp line. Yeah. It's sort of a WYSI line where the interstellar medium sort of goes around where the sun can like push it away.
Yeah, so it's like the wake of a moving object.
Exactly.
And that surprised me. I imagined it would just decay like 1/r² smoothly to zero, but it doesn't do that.
It does decay smoothly. The thing is that there's a point, and I guess really all physics boil down fundamentally to Newton's laws of forces, where the force of the sun can no longer repel the interstellar medium.
Right.
There's a point where that just doesn't happen anymore. It's not an exact point, but there is a point where you're just in the interstellar medium, and the sun's influence just doesn't matter anymore.
Yeah.
But of course, if you're really close to the sun, like close meaning like an Earth or a Jupiter, where the sun's magnetic radiation just keeps out the interstellar medium.
Yes, that means you could define like a boundary of the solar system.
The heliopause.
I know, which I thought it would just be completely arbitrary, but there's actually an edge of sorts.
Right, but like I said, it's a fuzzy edge, not a true edge. And you can also say too that the even though the heliopause is where the interstellar medium sort of overcomes the forces of the sun, it's not like the sun's particles stop at the heliopause.
Well, I know in the corona, there's a point where it's actually supersonic and it generates a lot of heat and such, and I don't really know if that kind of thing happens at the heliopause.
I doubt it. There's very little interaction going on.
Right.
But like I said, it's all fuzzy.
Yeah,
fuzzy lines.
Well, very good. Anyway, so the one that got my attention, I actually talked to my class about it yesterday, telling them things that appear to be wrong. One of the Cisco operating systems has a serious vulnerability that lets people bypass authentication entirely and implant malware on it. And they infected something like a few days ago. They said they had infected 42,000 of like the 60 or 80,000 exposed devices, but then mysteriously they all got uninfected. And now it has turned out that it's not, people are not quite sure what happens, but the current theory is that this was the bad guys improving their attack and switching the implant to an implant that can't be detected by the tool that was being used then by requiring an authentication header. So when you use a better scanner, they now say 60,000 of them are still owned. And the original implant was not very powerful and couldn't survive a reboot, but they could create new accounts, which would survive a reboot. So if you've been using Cisco iOS XE, you're probably in big trouble. Your stuff is probably owned, and the reports are changing every day and saying you really need to check your device to see if it has malware on it. And it's not entirely clear what the indicators of compromise are. So anyway, it's real important for people running that version of Cisco to be aware there's big trouble out there. And of course, it's not going to help you now, but you never should have exposed your administration's page to the internet. That should have been behind a VPN concentrator all along. But if it wasn't, you probably have trouble by now. Anyway, let's go on to you with the data poisoning article, which I thought was wonderful.
Right. So AI hacking race has begun. um, there's a new AI poisoning tool called Nightshade. What it does is it subtly changes images that are imperceivable to the human eye, but it really confuses AI when it uses it in the generation process. So when you train on this data, it just gets really confused. So this is an article by Melissa Haikidia on, let's see, this is MIT Technology Review. And the product is called, or the software is called Nightshade. And artists can run it on their artwork. And like I said, when models train on infected artwork, it just comes up with weird results. And there are some examples here in this article, in the MIT Technology Review article, where it says, you know, if you use a clean model, you get, like, you ask for a dog, you get a dog. You ask for a car, you get a car. You ask for fantasy art, you get some nice fantasy art. Ask for a cartoon, etc. But when you poison the sample, so here's 300 poison samples in the data. What?
You want to share the screen?
Oh,
yeah.
Oh,
there we go. Good.
Yeah, there we go. So first I'll show the article. This is the MIT Technology Review article. I'm sorry about that, everyone.
All right.
I'm sorry. Yes, I'm an expert at technology. So they say. So this is the article that I was talking about with Nightshade. And so there's a small image here. We're going to blow it up. So here we have a clean model of a dog, a car, a handbag, hat, fancy art at the top. And it looks pretty normal. But if you go down to like 300 poison samples, oh my gosh, this gets a bit much. So the cat looks all like distorted. The cow, is that even a cow? I mean, what is that at this point? Cow doesn't have eyes, looks like it's been bred near Chernobyl. Toaster is a little weird. It's making like bacon toast. The cake actually doesn't look that bad, but it looks like the plate is also cake. Anime. So this anime art reminds me of, do you remember a long time ago when there was that woman who tried to fix the Jesus painting and just completely messed up? Oh, it was really funny. Anyway, so this is the anime painting, looks really bad. The woman is missing fingers. It doesn't look very realistic. And yeah, so it just poisons the artwork. And there's other examples here too as well. So if we go back, we can look at the poison versus related prompts. So if anyone's playing along at home, and if you want to look at the original source image, you inspect the image, copy the URL. We'll open up a new tab, paste it in. There we go. Okay, now we have the image. So here we have the poison concept of the clean model versus the poison model below. So a painting by Michael Whelan. One looks normal, one looks bad. Oh, the dragon. Look at this one. So here we have a dragon and a clean model at the top and something that looks like stones.
And you move it to the left, your face is in the way. Oh yeah, good. Oh, so it just turns into like random rocks.
Turns into random rocks. Yep.
Well, you know, it's powerful, but I highly doubt that this will really generalize. I mean, I've done some projects with poisoning, and the poisoning usually has to be customized to the particular model.
Right. It'll be interesting to see how this goes. And also, now there's going to be some pushback from the AI people to unpoison models. So there's this race that's going to start happening.
Right. And I mean, there's a defense where you just detect which ones are poisoned. So, you know, just like malware and anti-malware, it's going to go back and forth.
Yep. The race has begun.
Yeah. All right. And so there's Google has added a new Tor-like feature, or they're going to add a Tor-like feature to their browser to hide your IP address. Now, I don't really understand why people want to hide their IP address unless you have a physical stalker trying to track your physical location. It doesn't seem to me like that's a significant risk of privacy invasion like cookies or anything. but people, anyway, they're going to add something. However, the first version of this is just going to run your data through a Google proxy. Now, Google is the main person invading your privacy anyway, so handing all your data to Google is hardly a step up. However, they claim later they'll go first through a Google proxy and then through some unspecified third-party proxy. So possibly your IP address will not be readily apparent to Google, and it will only have the 300 other cookies and marks it's made on your machine to track everything you do. Google has done this before. About 10 years ago, they tried to claim they were anonymizing your, they were not tracking you anymore because they would remove the last octet of your IP address while still retaining all the cookies, which was just a cynical, transparent attempt to fool a regulator to make they think they weren't tracking everything you do when they certainly still were. And so anyway, I'm very skeptical, in case you can't tell, that this is actually going to provide any privacy to people. And I found another article here on the Register where they talk about how Google was in court, and even Sundar Pichai, the CEO, couldn't explain what this Google privacy button does. They have a privacy button that says Google won't collect your data anymore, but they looked and it totally does collect your data. It just stores it in a different database at Google, and they call that privacy. So, you know, it's very hard to believe that Google could give you anything to enhance your privacy because their entire business model is targeted advertising. So apparently it's all just trying to whitewash their stuff. Anyway, let's go back to you with something I was asking just last night. Can the GPU makers make CPUs and vice versa?
They absolutely can. And NVIDIA in particular has been looking at, or I think they bought ARM a long time ago, a few years ago.
ARM just made an IPO. It's still on, so I thought they're independent. Well, I mean, I don't really know. Okay.
But the GPU makers absolutely can make CPUs if they wanted to, and NVIDIA wants to. So this is the article in Reuters, and this is by Stephen Nellis and Max A. Cherney. What's happening is that NVIDIA is going to start making ARM-based PCs, and these ARM-based PCs are designed to run the ARM version of Windows. So this is a major GPU manufacturer getting into the CPU space, which is interesting, which also makes me think that Intel is also going to be switching gears here soon too, because I know Intel made a huge investment in RISC-V. And that is something that I really like too. I like RISC-V just as a person who likes standards.
Mm-hmm.
So if NVIDIA goes down this ARM route and starts being successful with these ARM PCs, I think we're going to start seeing a new processor war of sorts, just like the early 80s and the early home microprocessor wars, where you had Motorola,
everybody
you had Intel,
1 gigahertz, I remember.
Yeah, you had ARM at the time, you know, all sort of competing for, you know, desk space before Intel sort of won that fight. Now, ARM is gaining popularity again, making a bit of a comeback. I say a bit, mainly in, you know, Macs and low powered PCs, not so much on the desktop. But it is entirely possible to make ARM chips that are just as powerful, if not more so, than Intel chips.
Oh, yes. And they use much less power.
Yeah. Well, that was actually the original idea behind ARM. ARM was not designed specifically around using less power. The idea was that the original people who made ARM, the Acorn people, they wanted to make a really fast CPU. And they found that the limiting factor was the heat generated. And so they would have to slow down the clock and everything. So the original idea was that they would just make it more efficient so they could run it hotter and, you know, faster.
Yeah.
And so absolutely, ARM was actually designed from the very beginning to be an efficient powerhouse.
Yeah. Now, I had a student last night tell me that the new RISC-V ones are 30% better than ARM.
Mm-hmm.
He said, therefore, they'll take over. And I said, well, it's not that simple in the world of business. ARM has an advantage in installed base. So if they play their cards right, they might win in the marketplace, even if their product is 30% inferior. But we'll see.
Well, here's the thing. Risk is not only going to be faster, Risk 5 is not only going to be faster, it's going to be cheaper.
Right.
Which I think in the marketplace means a lot. If they were the same price,
that's
I would
why
agree.
it's up to ARM to adjust their pricing. If they make their price too high, then people will go to Risk. So, but on the other hand, they have the advantage of being here earlier, so therefore probably more mature. And you can. It's a business job now.
Right.
How do you market it? How do you price it? A lot of companies do this, like they own something, but then they rest on their laurels instead of keeping up, and the new disruptor wipes them out.
Mm-hmm.
Yeah.
I mean, ARM was never really meant to be in the current place that it is. It was designed for Acorn desktops in the 80s. And then someone said, oh, these are pretty efficient. We could use this instead for, power efficient usage like mobile devices and like video game consoles and stuff. And then they just sort of ended up in this sort of taking over the mobile space. But it's all through leasing. So if you're wondering, like, how does Apple make ARM? It's not that it's open. They have to lease from ARM.
Yeah.
Now, RISC-V is open. Anyone can make a RISC-V chip, and it's just uses open standards. So like I said, I'm a huge fan of RISC-V. I do hope it wins. I would like to see it even overtake Intel.
Well, I remember the old arguments from 30 years ago about Windows versus Linux. They said, well, you have to pay for a license for Windows, but you don't for Linux. That's a huge advantage. But in practice, that wasn't such a huge advantage. Microsoft's other advantages caused it to greatly dominate.
That is true. So in the world of software, you have, of course, open source software and closed source software. And open source software, while very robust, is usually about 10 years behind where the commercial software is.
That's right. So the fact that you pay for it means they have enough money to pay a bunch of developers to do all kinds of boring things like work on the UI and make all the drivers you need and all that.
Right. And you will be buying RISC-V chips. So there will be people actively developing it and trying to make the best chip to sell on the market. So I don't think this is an apples to apples comparison between open source software and closed source. And there are a lot of spaces where open source software has absolutely taken over.
Yeah.
On the server market, of course, Linux has completely taken over. But in terms of just like everyday stuff, you have things like the OpenSSL library, which is running on all our systems, SSH running on all our systems.
Yeah.
You have like the Blender 3D program has basically taken over, 3D spaces. There are a few places where open source really has just come out on top. It's just the operating system itself. Most users just want something that'll run their programs. They don't really care about, anything else. And Windows works really well for closed source, software that people want to run.
And a lot of those open source libraries are maintained by people that are being paid by the for-profit companies.
Right.
Not really free work done by hobbyists.
Exactly. Well, except for like curl and a few others. I think curl is completely like hobbyist.
Yeah. But that's, anyway, this is the joy of capitalism. Anyway, all right. Well, I got something I saw here about Graph Runner. I didn't know about this at all. There's a Daft Hack GitHub repository, but apparently Azure uses something called the Graph API to control your Azure cloud infrastructure, and you can now use Graph Runner to exploit it. And what I saw people say is that existing security tools do not detect the use of the Graph API, which I'm not sure, but I suspect this is true because I know cloud security is a rapidly developing and, probably not very mature field right now. So it's an interesting tool and an interesting topic to figure out how to exploit cloud infrastructure on Azure. And the last one was an article which is here at PC World saying that Windows 11 by default will encrypt your SSD, and it will ignore the hardware encryption built into the SSD and use software-based BitLocker to encrypt the SSD, which will slow it down drastically by up to 45%. So they say, here's how to fix it. You know how to fix it? You turn off the BitLockers. You don't encrypt it anymore. I'm saying, I'm not entirely sure that is something you want to be doing.
Yeah, most users should not be encrypting the hard drive, period.
Well,
Ever.
if it's a portable device, you kind of have to, because you're going to lose the whole device.
So the problem with encrypting hard drives is that you have to ask yourself, what is more valuable to you? The data on that hard drive or your privacy? And for most end users, it's the data on the drive.
But you're going to have your passwords and credit card numbers and everything on there.
What you do is you get a password manager, like Bitwarden.
That would be better. Yes.
Yes, and you use that instead.
But most users don't know that, and they just have a notepad file on the desktop with their stuff in it.
I used to work with the San Francisco community trying to get people's computers working, and people would come to me all the time because they heard about encryption, and they're not that tech savvy, but they think, oh, I need to encrypt everything, and the hackers are going to come. So they encrypt their hard drive, and they come to me and they're like, I forgot my password, or my system can't boot. Can you restore all my files for me? And I'm like, dude, you encrypted your hard drive.
Well,
no.
Yeah. Well, you're right that home users, and for that matter, the first effect of any security boundary is to lock your authorized users out.
Yes.
You're right. Certainly, you don't want to do this to your work PC. It'll almost certainly violate your company's security policy.
Actually, no, work PCs are the PCs that should be encrypted via, the security policies at your company.
And then you presumably have a recovery mechanism managed by your company.
Yes, they have recovery mechanisms built in. Most people that do this at home do not have recovery mechanisms.
Yeah. Well, they say Windows 11 Home does not encrypt by default.
And it shouldn't.
Didn't think of that. I know, but apparently, but a lot of people get the pro version at home. And apparently, if you do that, you might want to turn off the encryption if you understand the risk.
Yeah. No,
but you're probably right that from a tech support point of view, turning on encryption is probably a bigger risk than turning it off.
Right. Like I said, what do you value most? If in the event of something going wrong, losing all your data, or in the event of something going wrong, someone being able to read data off your disk. And for most people, it's being able to recover their data because they have pictures of their cat, and people at their birthday parties and stuff that they really want to keep. So,
well, this happened to me yesterday. I use LastPass still, and suddenly LastPass said, you can't keep using your two-factor authentication app. You need to reseed it with this QR code. And so when I did that, now I had two on. They say you have to delete the old one, and I deleted the wrong one and got locked out of my LastPass. And then they said, oh, you can just recover it with SMS. And I'm like, well, that's handy at this moment. But that just reminds me I need to get the hell off of LastPass. And I don't know why they're forcing me to reseed it. They did it to people 6 months ago because of the hack of LastPass. And I wonder if they got hacked again, or if they're just 6 months late telling me to do it. But in any case, I'm looking into migrating to Bitwarden. Many people that are very intelligent have said LastPass is a bunch of idiots and you have to quit using them. And I'm pretty convinced that's true. LastPass does seem to be too stupid to be in this space. And Bitwarden seems a lot better.
Yeah, Bitwarden has been fantastic for me. It is open source.
You don't get your own instance on your own server. I was thinking it'd make a good project for my students.
I would not recommend that. Their cloud services work just fine. And
of course, but making your own would be a good exercise, system administration and stuff. Oh, and running your own in the long run is probably not good because you're going to forget the password and get locked out of your stuff.
Right. But for corporate, if you're running a corporate network,
yeah,
that's where you would want to build your own, because I know at least at the government, they were like, no, you can't have password managers. And I was like, and on the security team, I was like, no, we need our users having password managers. Like, this is insane.
You can't have the data going to some other company.
Exactly. Yeah. Exactly. So that was the thing. You just can't have it going to somewhere else. So if you can sit it on-prem, that's where that helps. But I would not recommend average users setting up their own thing.
And the same thing for large language models. They say you can't be using those public ones because that's sending our data off to somebody else who you don't know what they're going to do with it, but you could run your own LLM on your own server.
Exactly.
Yeah. All right. Well, that's it for this one. And I'll have another one on Friday.